Is Patty Lavasser, and she is speaking to us from UMass Amherst. And she's going to talk about the challenges of assessing Wellfleet's diamondback terrapin population. And we can see your slides, Patty. Perfect.
Make sure Patty's okay. Can everyone hear me?
Yes, we can hear you.
Okay. Great. Well, thank you for inviting me to this conference. I'm excited to be here and share some of my research on diamondback terrapin population here in Wellfleet Bay. I am a PhD student at UMass Amherst and work with Mass Audubon at Wellfleet Bay Wildlife Sanctuary. So let's jump right in. So I often get asked, why are they called terrapins? What is the difference between a terrapin and a turtle? Well, diamondback terrapins are called terrapins because that is what the Europeans called them when they arrived here. And I'm not quite sure if they carried that name over from Europe, since that is the term they use for most turtles, or if they derived it from taurope, which is the name for turtle in the Algonquin Native American language. Either way, terrapin is just another name for turtle, and it stayed that way as their common name. What separates the diamondback terrapin from all other pond turtles is that it is the only species of turtle in the entire world that is restricted to brackish water environments. So yes, they are a turtle, but a highly specialized one. And they occur along the Atlantic coast from Cape Cod, Massachusetts to Corpus Christi, Texas. And like most turtle species, diamondback terrapins face a myriad of threats, including habitat loss, predation, road mortality, and drowning in crab traps. And despite all these known threats and suggestion of decline in many states, the population of terrapins throughout their range is mostly unknown. Now, this is relatively alarming. How can we conserve and manage a species when we know virtually nothing about the size and health of the population? Well, this is in large part due to the current population sampling methodology and the ecology of terrapins themselves. So let us start with the current sampling methodology, capture, mark, recapture. This is a well-established and most widely used method for conducting population studies for diamondback terrapins, as well as many other species, where a sample of animals in a population are captured, marked with an individual identifier, and released, with some individuals being recaptured in subsequent sampling events. This builds what we call capture histories, where you can see an individual terrapin in each row here on the left, with a column for each sample day, and either a 1 if they were captured, or a 0 if they were not captured during that sampling day. As you can see here, terrapin B was not captured on the first day, but captured on the second and third day. This gives us information on our probability of capturing a terrapin. These capture histories are used in a statistical model to estimate probability of capture and population size. However, when using this method, the area you are sampling from and estimating population size is not defined. It's the uncertainty of what the population estimate means. Population size of what? When the size and location of the sample area is unknown, you are unable to compare estimates between other populations. It also leads to estimates that are less accurate, especially if the researcher decides the population size represents an area much larger or smaller than what was actually sampled. So let us visualize this. So here we use capture, mark, recapture to estimate the population size of largemouth bass in a pond. In this example, if we ask the population estimate of what, we can confidently say it is of the pond. capture mark recapture did not define the area of the closed pond. It was already naturally defined. We can also, in theory, compare largemouth bass populations in other ponds of similar size. So capture mark recapture can...
Patty, I'm so sorry to interrupt you for a second. And then Patty, so can you unmute yourself and keep going? Sorry for the interruption. And a reminder to everyone to mute your microphones, please.
Did the screen share stop sharing, or am I okay?
No, so I see it in presentation mode right now. Or excuse me, I'm sorry, it's in
oh goodness, okay.
And if it's stuck there, that's fine. But yeah, it looks like you're getting it back to presentation. Perfect, and I can hear you. So please continue. Sorry for the interruption.
Okay. Okay, so we're looking at the population size of largemouth bass in a pond. So if we were to ask the population size estimate of what, we can confidently say that it is of the pond. Capture mark recapture did not define the area of the closed pond. It was already naturally defined. We can also, in theory, compare largemouth bass populations in other ponds of similar size. So capture recapture can work in this scenario, but we know the majority of wildlife species and their habitats are not this simple. Now let us visualize diamondback terrapin habitat here in Wellfleet Bay. It's not so simple. The major challenge here, other than that it is very large, is that unlike the closed pond, this habitat is open. It is not feasible to sample the entire bay. So what if I sample a smaller, more feasible area? But where in this area did I sample? What if it was just over here? I only sampled from that small east corner, and I stated that my estimate of population size was of the entire cove. We did not adequately sample the entire cove, and so we can presume the estimate is not very accurate as a representative of the entire cove. So I hope these examples clarify why an undefined area is a major issue when conducting mark recapture. Conducting mark recapture, sampling, and estimating population size.
Patty, I'm so sorry to interrupt again. So I think someone accidentally shared their screen, so we cannot see your slides anymore.
Okay.
So can you hit share screen again, please? And I'll let you know when we can see them. We're fine. We got plenty of time. We'll figure it out.
Can you see it now, or?
Not yet, but there's usually a little bit of a lag. When you hover your icon over that the share screen thing, does it say share content?
Well, it says hide share options now.
Let's see. Okay, I'm going to try this. Bill, I think you accidentally shared your screen. So can you find, it's the square with the arrow that says share content. Maybe you have to unshare your content before Patty can log in. Thanks for your patience, everyone. Here's where virtual grace comes in.
Yeah. I also can share my screen. I have Patty's presentation. Oh,
excellent. I see Wellfleet Harbor now.
Okay.
And it's so it's in, yep, and we're back into presentation mode. Thank you, Patty.
No problem. Okay, so I hope that you can see with these examples why an undefined area is a major issue when conducting mark recapture sampling and estimating population size. So in addition to the challenge of undefined space, the open, dynamic, and variable tidal systems where terrapins live are often difficult to access and limits our choice of capture method. This leads to capture methods that are oftentimes habitat specific. So in addition to undefined space, dynamic tidal systems, and capture methods, terrapins themselves are elusive. They are hard to catch and exhibit seasonal variation in behaviors and movement that depend on sex and age. These challenges often lead to low sample sizes, which makes it difficult to estimate population size. Elusive and highly mobile species are not uncommon in our world, and a method has recently been developed called spatial capture-recapture. This method is an advancement of the well-established capture-recapture framework. Without getting into the nuts and bolts of the statistical model, SCR, or spatial capture-recapture, addresses one of the main challenges of traditional capture-recapture by explicitly defining the area you are sampling, which defines what that estimate represents. This method also takes and uses spatial locations of captures to provide information on animal movement and space use. Traditional capture-recapture does not take or use spatial location information. And lastly, SCR estimates detection not only by whether or not an individual was captured more than once, but also using the spatial location information of those captures. And you can look at different environmental factors such as wind, temperature, season, and tide to better inform and explain your ability to detect or see an individual. The advancements of this model allow us not only to estimate population size, but also the density or number of turtles per unit area, which, unlike traditional capture-recapture, can be compared between sites and monitored through time, not just within Wellfleet Bay, but other sites in Massachusetts and in other states. And most importantly, it provides more accurate estimates given terrapin ecology. So my research so far was to develop standardized monitoring protocols for terrapins within Wellfleet Bay using two sampling methods, spatial capture-recapture and visual head count surveys, which I'll talk about later in the presentation. The second objective is to test these methods. Do they work? And evaluate these methods in estimating detection and population size. The spatial capture-recapture method was conducted at two locations here in Wellfleet Bay, Chipman's Cove and what we call the Run off of Wellfleet Bay's Wildlife Sanctuary in 2018 and 2019. The first study design, or 2018 method, looked something like this. We would have line transects of a certain length and width, our defined area. Observers would walk the transect and capture any terrapins within that area along the transect. And that fairly small transect area is also the capture location of each turtle. So here's what it looks like at the two study areas. Great, so it looks like we have a solid study design that will collect information we need. So let's go and catch a bunch of terrapins. All captured terrapins were marked with a small PIT tag, which is a small electromagnetic microchip that contains a unique identifying number. We also take morphometric data such as size, age, and sex, and then they are released. So how did this transect method work out? Well, it didn't go quite as planned. We did not capture very many turtles at all, and we had virtually no recaptures. So that was a bummer. Now, the low recapture rate was not because they weren't there. We were seeing them, but we were restricted to those transect paths, and the transects left much of the study area not searched. So it was back to the drawing board to come up with another study design that would work better. The transects were too restricting, but were needed in order to spatially define our area and capture locations. So how can we improve this design? I then came up with the pillowcase idea. Pillowcases are widely used to safely handle reptiles, and they can easily be labeled, which we need to keep track of which turtle was caught where. Now we were free to search more of the study area. Their surveys all had a handheld GPS that uses satellites to track where we searched, shown here on the maps of each site. This was used to identify the search area, which is used to define space in the spatial capture-recapture model. When we caught a terrapin, we used the GPS and took a latitude-longitude point of its exact location. That is stored as a point number, which is matched to the pillowcase number. So your first GPS point of your first turtle captured would be stored as 1, and that terrapin is placed in pillowcase 1. Your second stored as 2 and placed in pillowcase 2, and so on. Now, when you are finished your survey and return to shore to record all of your data, you will know exactly which turtle was caught where. So how did this new method work out? Well, much better. We captured more than twice the number of terrapins than in the previous year, and more than 10 times the number of recaptures. Now, we still do not have as many recaptures as we would like to have, but this is a big step in the right direction. Before I show you our population estimates, I want to share what we found for our ability to see and detect terrapins and the environmental factors that influenced our detection. The first environmental factor was cloud cover, which had a small but significant effect on detection at both sites, but under opposite conditions. In Chipman's Cove, our chances of seeing and capturing terrapins was greater when it was more cloudy, and in the run, our chances were greater under clearer skies. This could be in part due to the different benthic substrate of each site, where Chipman's Cove has dark mud with lots of spartina grass, and the run has lighter sand with no vegetation. Day of the year or season also had an effect. As you see in Chipman's Cove, detection was highest in May and declined as we went through June. Now, this makes sense given what we know about terrapin movement and ecology here in Wellfleet Bay. Chipman's Cove is a place where they congregate in early spring to mate. In the run, you can see here it looks quite different from Chipman's Cove, and that our highest detection was in mid-June. This is really cool to see because we know this site is not where terrapins aggregate, so we expect detection to be low in May. And we suspect terrapins to begin to move and spread out to nesting areas and other parts of the bay starting in June. And these results support that. Another interesting influence on detection was tide height, but this only had an effect in Chipman's Cove because we always sampled Chipman's Cove around high tide. Our results show that detection was highest during high tidal amplitudes. Now, this could be a result of there being more flooded area for us to search and find terrapins, or terrapins were taking advantage of using the areas of the cove not always accessible, or possibly it was a combination of both of these factors. Although these findings are interesting and informative, I do want to bring your attention to the detection estimates. Detection is estimated from 0 to 1, where 0 having no chance of seeing a terrapin to 1 being guaranteed to see one. As you can see, our detection estimates are very low, and that is because terrapins are hard to catch. And this low detection has a direct effect on our population size estimates. Now let's look at these estimates. So these estimates represent the population size at each site only during May and June. Our population estimate for the run was about 2,100 individuals, and in Chipman's Cove, about 3,000 individuals. In addition, you can see that at both sites, there are estimated to be more females than males, which is an interesting finding. The vertical black lines extending from each point estimate is our error, or our uncertainty around these estimates. You can see at both sites the error is quite large and tells us our estimates are not very precise. Now, this is in large part due to our ability to detect and catch terrapins. If you remember, our probability was very low, and this has an effect on the precision of our estimates. Being able to successfully see and catch terrapins is a widely known challenge and will continue to be a challenge with mark recapture methods. However, although more advanced spatial capture-recapture models may not help you catch more terrapins, they do provide more accurate and realistic estimates than traditional capture-recapture, even if they are not precise, and they allow you to compare and track estimates between populations elsewhere, because area is defined and spatial processes are included. Additionally, SCR provides information on movement and space use, as well as sex ratio and age structure. But they also share some of the same challenges of traditional capture-recapture. This method is extremely intensive and expensive to implement, which often leads to small and few study areas. Is there an alternative method that could address some of these challenges or costs of mock recapture? Now I'm going to introduce our second population monitoring method, visual head counts. Point counts are widely used in bird population monitoring. Birds sing, they can be heard, therefore they can be counted. Terrapins have some aspect of their behavior that is similar to birds. They do not sing, but they surface to breathe. We can see their heads, so we can count them. This is not a census, as we know we are missing individual terrapins that are beneath the surface, just as we miss birds that do not sing. It is an imperfect count. These point counts are repeated multiple times at the same location and at many locations, and there are statistical models that exist to analyze these counts to produce estimates of detection and abundance. So we developed a point count survey design, and it is quite simple. At each site, the observer conducts 5 sweeps or scans from one side of the shoreline to the other, counting all heads observed within 100 meters of the survey point. There is a 1-minute break between each scan for 5 independent counts for each survey. And these surveys take about 11 to 15 minutes or so to complete, so they're fairly quick. So because these surveys are quick, you can do many of them in many places and go from only 2 locations with mock recapture to 39 locations here in Wellfleet Bay. The study area has now become quite large. Surveys were conducted at each of the 39 locations multiple times from May through August in both 2018 and 2019, which means we have repeated counts that can be analyzed with specialized statistical models. This method uses a statistical model called the N-mixture model that is built for analyzing repeated counts of a closed population. It is comprised of a detectability model and an abundance model that work together to produce estimates of true abundance at a site. For this presentation, I'm going to show you the results of the 2018 surveys. So let us look at what we found for detection. We found air temperature to have a significant effect on detection. As you can see, our probability or chances of seeing a terrapin head poking out of the water increases as air temperature increases. This is cool, and this is what we would expect given what we know about terrapin ecology. Another cool thing we found was how wind affects detection, where our chances of seeing terrapins decreases as wind speed increases. And this makes sense because when it is windy, the water gets choppy, making it harder for us to see. So based on these results, we should survey during warmer temperatures with low wind to maximize our ability to see heads. So now let's look at what we found for abundance. For abundance, we do have abundance estimates for each site for each survey, but that is a bit too much to graphically show here. But I want to show you how estimated abundance changes through the season. You can see here that on average, abundance at each site declined as the summer went on, which supports what we have learned with the spatial capture-recapture results, that terrapin movement increases around mid-June and they disperse throughout the marsh. So what are the benefits and challenges to this method? Well, headcounts provide estimates of local abundance as well as information on movement patterns. They are non-invasive, quick, cheap, and can cover large areas. However, we cannot gather individual identification or information on sex and age structure. So what I hope I conveyed in this presentation is that yes, conducting population estimates on diamondback terrapins is challenging, but it's not impossible. This research has shown that both methods have obvious value, and if used together, visual headcount and spatial capture-recapture methods have the potential to track estimates of local abundance patterns at large scales, while simultaneously estimating demographic parameters such as age and sex at local scales. And lastly, this research has produced systematic, standardized survey protocols with quantifiable effort for both methods, which is crucial for producing estimates of abundance that can influence terrapin population management and conservation. Thank you very much.
Patty, that was excellent. Imagine a round of applause coming from all of the speakers, which you would most definitely be hearing if we were all in person. So I do have a number of questions for you. And the first one is, can you please review how you go from detections to abundance estimates?
How I go through them.
Or how, just how you, so how do you, or trying to think what the person was at. So how do you translate? So with mark recapture techniques, I think the question is, how do you take the information that you're getting from detections and then like translate that to abundance estimates? So I think it's like a technique question, a methodology question.
Well, that is done in a statistical model, which I didn't want to bore and or convolute the presentation with kind of the nuts and bolts of the statistical model. But the SCR, the spatial capture recapture, has a special model, and it's a hierarchical model similar to the N mixture model, where it has two different models that uses fancy statistics to estimate your detection probability based on your raw data, based on those capture histories that I talked about. And that is used in the abundance model to help estimate abundance. It's all done we don't have to do it by hand because technology has, graced us with that. And so we use a program called R, and it's basically a software that does all of that complicated math for you. So hopefully that answers the question, but it's all done in a complex statistical model that estimates both of these detection and abundance parameters.
Yep, I think that covers it. Let's see. And the next one is, how do these abundance estimates compare to other regions along the Atlantic coast? Do we know that information?
We really don't. So there's been population estimates in other areas, but they were, as far as I know, there could be some new information that I'm not aware of yet, but they used capture recapture, and they were from quite a few years ago. And like I mentioned in the presentation, you can't accurately compare estimates of traditional capture recapture. So what I'm hoping is that the spatial capture recapture methodology will kind of take hold, and more researchers will use it so that when they conduct, can be compared. But Wellfleet Bay does have a fairly healthy diamondback terrapin population, but that's because of how protected the marsh is and how large the marsh is. So
great. What do diamondback terrapins eat?
A lot of different things. So they primarily eat snails, and when crabs will go through molting, they'll take advantage of when the crabs are soft. They will eat mollusks to an extent. The larger females, smaller females can't really, don't have the jaw strength for that. They'll eat grab, so even dead fish or dead animals, they'll scavenge. So, but their diet primarily consists of snails.
Interesting. So if anyone has more questions, so it looks like some are coming in, you can type them in the chat box. And I have to say, I remember being introduced to mark recapture techniques as an undergraduate, and I wish you gave my lecture because that was such a good overview.
Thank you.
All right, next question is, what's the prognosis for terrapins with salt marsh loss in Wellfleet Bay? And that could actually apply to a larger region too.
Yeah, so it has, it will have and does have a significant effect on their survival. So we know that they're salt marsh specialists. They require not only that mix of freshwater and saltwater to live at their best, but they also need the food resources and the nesting resources that make up salt marshes. So if salt marshes disappear, their food disappears, their nesting disappears, and so their populations will disappear as well. So it's all connected.
Thank you. With climate change and warming, is diamondback terrapin habitat likely to move northward?
You know, that has been talked about. We suspect, or I suspect, that it probably will. It'll probably be very slow. Here in Massachusetts, I think we would find that out if we start to see terrapins up north. I think it's Plum Island Marsh. I might be mistaken, but there's pretty extensive marsh further north that does not have terrapins at this time because the water's too cold. But maybe if we start seeing them there, that would be proof that they'll migrate northward.
Is anybody up there looking for them? Is that part of monitoring efforts?
Not that I'm aware of, no. I know that someone has, because I don't remember the year, but it was, no, they're not here yet. But I would assume there's a lot of work that goes on those marshes, particularly with restoration. And so I feel like somebody would see them if they were there.
All right, are there any other questions for Patty? I'm not seeing any more in the chat box. And we will have some time after Brian's talk too. So, you know, he'll be answering questions then. But if you keep thinking of questions for Patty, then you could just type them in and we'll get her at the end too. So I think somebody's, oh, right, there we go, we're good. Okay, Patty, thank you so much. Picture a round of applause coming from all of the participants. We've got, I think, 99 people at the tops we had that are listening to your talk. So thank you so much. An excellent recovery after interruptions. So I know that's not easy.
Yeah.
All right, our next speaker is going to be talking to us about sharks. His name is Brian Laguerre, and he works with Center for Coastal Studies, and he's also Amherst. And his talk is titled "What They Do in the Shallows: Fine Scale Movements of White Sharks." And Brian, you can, oh, perfect. Yep, I can see your slides.
Can you hear me?
Now I can hear you. Yeah.
There we go. Good morning, everybody. This is interesting doing a virtual talk and I can't see your faces. My name is Brian Laguerre. I am a researcher, biologist at the Center for Coastal Studies up in Provincetown, and I'm also a PhD student at UMass Amherst, working with Greg Skomel and Dr. Andy Danilchuk. And today I'm going to talk to you about fine scale shark movement of white sharks in the project that I've started conducting over the last couple of years. This project is in direct collaboration with the Atlantic White Shark Conservancy and Mass Division of Marine Fisheries with the seafloor mapping program here at the Center for Coastal Studies. Quick little recap that most of you guys in the audience are probably familiar with. After a moratorium on culling had ended in Massachusetts in the 60s, in the Marine Mammal Protection Act in the 70s, a rebound of the seal population has been allowed to come back with pretty perennial haulouts here on Cape Cod with a decent number of animals here year-round. In addition, protection of white sharks in the 90s and the early 2000s has allowed that population to come back over time. With white sharks using shallow water to hunt and prey, they are often sharing space with us, and that has become a major concern for both recreational users and managers of the area, as these sharks often hunt in extremely shallow water on the backside. And often what we're finding is there are lots of human shark overlap, which is leading to us really needing to understand how these sharks are using the shallow water habitat on Cape Cod. We have had a few incidences along the backside of the Cape, including one fatality in 2018 And this has been followed up by a fatality up in Maine in this past year, which has really emphasized the importance of understanding how, where, and when these sharks are moving and how they are using the shallow water habitats. To this point, the majority of the research in the area has been conducted by the Division of Marine Fisheries, Dr. Greg Scommel, and the Atlantic White Shark Conservancy, primarily Megan Winton. And they have tagged up to over 200 sharks, and actively right now they are about 197 actively pinging sharks in the waters in the area. Last year, they were able to tag 50 sharks, and all the research that I will be talking about from here on forward uses the sharks that DMF and the White Shark Conservancy have tagged. So in trying to grapple with the shared space and trying to understand what the sharks are doing in these areas, you know, we would like to understand how humans and sharks use the same water. Due to the recent recolonization has created a knowledge gap because we didn't have the technologies to really understand, you know, how the sharks were moving in the area because they weren't here in the abundances back 20, 30, 40 years ago. You have to go back further in time when they were more abundant. The objective of this research is to look at the biotic and abiotic influences of shark movement to better inform managers and the public and to create novel science. The method I am using is using fine-scale acoustic telemetry, piggybacking on the work that has been conducted over the last decade. In 2019, with support from the state, local fundraisers, and the town of Toro, we conducted a pilot study at the head of the meadow, about a mile of the beach, about a half mile off the beach. We created an array of acoustic receivers. What you can see on the right over here is the array of receivers that DMF maintains, including one right outside Wellfleet Harbor. In this little area, I'm using the same technology, but in a different configuration to track these sharks. The study design is to use the very dense, these are 200 meters apart, receivers to triangulate the position of the sharks as they swim through the array. We chose Head of the Meadow because it's both a popular recreational beach, has very interesting geomorphology, and there's a perennial seal haul out so we can start identifying questions on how and where and why they are using these areas. Being on Cape Cod and putting equipment into the ocean has unique challenges. Many of you are familiar with the marine disentanglement program we have at the Center for Coastal Studies, and we're always concerned about interactions with wildlife. So we've deployed all of our equipment with timed releases that will release the equipment from the sea floor, and so we don't have ropes in the water column that could potentially cause entanglement issues with whales, mullet, and other sea creatures. And also, we won't have things at the surface to obstruct views. Here at the center, I'm a part of the seafloor mapping program, and what we really bring to this table beyond deploying the equipment is we are mapping and quantifying the nearshore environment using our seafloor mapping equipment, including a sonar that collects both side scan and bathymetry of the area, so we can quantify the habitat in both constituents with the side scan imagery and shape and depth with the bathymetric data sets. So we can identify how they're moving through the troughs and amongst the troughs and across the bed forms. In addition to that, I deployed a whole suite of equipment to measure waves, tides, currents, light levels, temperature, and conductivity. Like many methods, if you're using a visual cue to count animals, it's going to be very difficult when we have areas that fluctuate in turbidity, like Cape Cod waters, in both mung and in suspended phytoplankton. So we will be also looking at how often sharks are present in even murky waters, so we can get an idea on how effective other techniques for counting sharks are. For example, some of the data that we collected, this is ADCB data. Up top is water speeds, down below is direction. And last fall, we were able to get a very nice data set that shows a very continuous back and forth of currents, both north and south, creating longshore currents. But we also were able to capture major storm events, a nor'easter towards the end of the study that moved and buried some of my equipment, which showed the water direction formed more of a rip current type of event. In combination with the environmental data that we collected, we were able to detect 31 individual white sharks over the course of 3 weeks. These sharks were present 40% of the time, and we had over 21,000 detections. And you got to remember that these are just tagged sharks. There are non-tagged sharks out there. So this is a significant number of animals in this area often. But what we're able to do is also look at presence here in relation to wave height. And we had some pretty significant waves where sharks were still present. So it was pretty rough out there. But when the currents turned to more of a rip current type scenario, they left the area, probably because it wasn't worth the washing machine to swim through that you might expect. So what can we do with this data? So we were able to deploy several dozen receivers in a dense array. We covered an area that has a seal hollow. We were able to calculate 1,928 individual locations of 23 different sharks and see how they distribute over the area. We're able to see how they're using the area in relation to both the bed forms and the seal hollow. And looking at how it's related to the bed forms, you can see that the dense area in which they're moving is often on that inner bar here, several hundred meters from the shoreline. So the majority of their movement is along this inner bar just beyond the break. What we're also able to do is look at how each point is related to the seal hollow by measuring the distance from the seals. And what you can see is that the majority of the density of this area, you can see that the sharks are more likely to be right up near the seal hollow than away from the hollow while they're traveling through head of the meadow. So they're spending more time possibly in that area due to seal presence and olfactory cues. We can start to look at individual sharks and how they might be just passing through the area, how they might be circling back and traveling. You can see this guy on September 19th did a lot of very torturous turns up by the seal hollow and traveling through up and over the bars or just in and out. Sometimes they're just passing through the array, traveling to another area. In addition, what we're going to be able to do is tie this into how sharks move regionally. This is a white shark named Whitaker, which was tagged on 60 Minutes last year, I believe. And you can see how it's moving up and down the backside of the coast over the course of last fall. This is a 2-month period of time scrunched down into 45 seconds. And you can see there's lots of movements, and it even ventures inside the bay towards Wellfleet Harbor a couple times, which is interesting because a lot of people always ask me, do the sharks go inside the bay? And the answer is yes. They are in there. It's not something necessarily to, fret about, but it's something to be aware over. And then ultimately, what we can do is really start to define the behavior on a very fine scale, looking at how they move amongst the bars in relation to the tides and in reference to the seals. And as you can see, there's very different patterns where this shark named Scarface is right now is near the seal hollow doing these very fine scale search patterns, where when it's away closer to the swimming beach, it was more in linear passing through type behaviors. So this is ultimately the type of data that we are collecting and analyzing. From 2019, we have over 300 individual tracks, and in combination with 2019 and the data that we collected in 2020, we're going to have a robust sample size to understand what these sharks are doing. In 2020, what we were able to do is we were able to expand the distance between receivers due to the quality of data at Head of the Meadow, another half a mile to the north. And we were able to deploy some receivers down at Nauset Beach to understand how they're moving. Although I haven't had the chance to analyze the data and create virtual positions yet, I have looked at some of the summary statistics for this. And at Head of the Meadow this summer, there were 69 individual white sharks that were detected moving through the array. A tagged white shark was present at least 51% of the time, and I collected over 80,000 detections. What difference is at Nauset Beach, we were able to detect 58 sharks, individual sharks. They were present 29% of the time, and I was collecting 28,000 detections. And when you're starting to look at data for way too long, you start to see patterns that you in the data that drag you into different areas. With that, I'm going to leave it open to some questions.
Thank you, Brian. That was great. All right. Okay, we have a number of questions for you already. So picture your round of applause.
Yay.
There we go. Okay. Do you what to start with? Okay. Do you know which model technique the Shark Conservancy used for their awaited population study?
Megan loves that that everyone always gets the question about how many sharks are around. I don't know the exact model. I know she is combining a combination of Mark III capture studies and applying it to acoustic data, and also using the visual censuses to inform these models as well. The details I don't know, but she can answer that at her next talk.
Okay, thank you. And so everyone, if you have questions for Brian, you can type them into the chat box. Let's see, can you talk more about the sensors themselves and how you get the data back from them? Do you have to physically recover them to get the data?
Yes, and that's the that's the hardest part about this. Putting equipment in the ocean's easy, getting it back is hard. So what happens is we have it's a two-part system where you have the tag itself that sends out a coded message, and then you have a hydrophone which records the message, and that hydrophone is the receiver that I put at the ocean floor, and then I have to retrieve that. So none of the data I collect is real time. I have to open it up like a Christmas present and see who visited.
It's a great description of downloading data, yes. Is this the same project that was the subject of Shark Week's 2020's Wicked Sharks program? It was fascinating.
Yes. Due to logistics and the fact that I had to get science done, I wasn't able to be featured, which was fine because I'm more interested in the science anyways. But yeah.
Great, thank you. As the seal and shark populations grow, do sharks have natural predators that could be attracted to even the playing field? Orca whales, for example?
Orcas are known to be natural predators. It would be very interesting if we could, if an orca population established itself here to start playing with them. But also orcas eat a lot of other stuff too. And so it would be a fascinating thing for the ecosystem around here.
All right, I'm going to switch over. Patty, can you take a few questions, please? And Brian, we've got more questions for you. I'm just trying to sort through them as they come in.
Sure. I think I answered the one that I saw on the chat, but was there another one?
So here, there's two questions, and I'm not sure which one you answered. So is there a Diamondback terrapin researchers network? And then what constitutes a sustainable population of terrapins for Wellfleet Harbor, for the two that I have?
Okay. So yes, we have, we started, I'm kind of the unofficial coordinator of a Massachusetts Diamondback Terrapin Working Group that's here in the state, but there's also a regional Diamondback Terrapin Working Group that extends throughout their range. And so these are groups of active researchers that are conducting terrapin work.
Yeah, and the Wellfleet Harbor one, just in case, I just saw your response, but just in case not everyone can see it, can you answer that one?
Yeah, well? I mean, it's really hard to kind of state a number or state a size of a sustainable population. That's something that requires knowing the baseline population and tracking it over time and seeing how the health of the individuals are changing. And, you know, when terrapins are looking less healthy, that usually means that maybe they're overpopulated or something's going on. But I do not think that's happening in Wellfleet Bay, based on what I've seen and what everyone working at Wellfleet Bay Wildlife Sanctuary and Barbara, all of the work that's been done. You know, it seems like it's a fairly healthy population with healthy females and some juveniles that we've seen in our capture efforts. And that's in large part due to the nest protection efforts and all of the work from the community of helping these terrapins. So it's hard to know, and that's what we're trying to keep going with.
Great, thank you, Patty. All right, next question for Brian. Some years ago, we had reports of thousands of pings in Wellfleet Harbor, but nothing since. Do we have an idea of how many sharks visit the harbor and how close they come to Mayo Beach?
I don't know that exact stuff because my work has been more focused on the arrays that we have on the backside. What we would need to do is deploy some equipment in Wellfleet Harbor that could record these, and we would have to put a sensor by Mayo Beach because, you know, Wellfleet Harbor is a bit turbid, so it's going to be hard to do any visual censuses of them for something that swims in the water. But they do go in the harbor. Yeah.
And we know that because there was equipment in there that was sensing for another study. Is that correct?
I believe so, with Greg. Greg Skolmo would know the exact details on that stuff.
Okay.
Abby, actually, it was receivers put out for a horseshoe crab study that we did at Wellfleet Bay, and that's where the mystery IDs were pinging, and then we found out that they belong to sharks.
Got it. Thank you, Jeanette. Brian, great work. Are there other researchers on the Cape beyond coastal studies, Division of Marine Fisheries, and the Atlantic White Conservancy that are studying sharks?
So I know that he's at Arizona State now, but he was at UMaine. A researcher named James Sulikowski is working on sharks in when you say the Cape, it's really Gulf of Maine as a whole. He's working on stuff. Several researchers at Hui are working on several different projects. Several researchers, I think, at Northeastern and the New England Aquarium are all working on various projects throughout the Cape.
Great, thank you. Let's see. All right, there's another question that, Brian, you are allowed to defer if you want. So what is your advice for body surfers and board surfers?
Yes. If it was me, I would be definitely following the guidelines set out by the National Seashore and the state, because they are lining up very well with the data I am finding, which is not swimming much beyond your waist and moving beyond the break. I know that is contradictory to what surfers want to do. So be careful, swim with groups, be in groups, know where any emergency supplies are, have cell phone handy.
Yeah, thank you. Yeah, and I was going to say, if folks haven't seen the Cape Cod National Seashore Guidelines, definitely check that out. You could just, type in probably, shark advice, Cape Cod National Seashore, and it should come up. But they've done a lot of work on communicating to the public and how to be aware and do what you can to keep yourself safe. So just a few more questions. Brian, for you, are folks surveying the seal populations? Have they seen changes in the seal populations since the shark numbers have increased?
I think I don't know the exact population estimates because they're very difficult, being a small portion of the West Atlantic population of gray seals, which goes from Virginia all the way up to Newfoundland. And there has been tagging studies that has shown seals moving from Cape Cod to Sable Island in Newfoundland within a week. So it's difficult for that. I believe there was a paper that I referenced, Pace et al., that had it starting to plateau a little bit. And I wouldn't necessarily say that's because of the sharks, although our seal biologist, Lisa Setti, would be able to answer these questions a little bit better. But it's probably reaching the carrying capacity for the seals.
All right, thank you. All right, I have a multi-part question for you, Brian. I'm going to see if I can break this down. So you've got lots of data regarding ocean conditions, water depths, currents. Is that data publicly available?
It will be when it's processed and published as part of my dissertation. The center has a general policy of, when we're done with the data, making data publicly available.
Okay. Over what area do you have the mapping data? Is it just the small area of the study, or is it the entire coast?
So it's the small areas of the study. We map during that period of time, and then we're going to relate it to other mapping that we have accomplished and also other data sets to extrapolate to other areas.
And if this questioner wanted to talk to you about raw data, how would they get in touch with you?
It's blaguerre@coastalstudies.org.
And I'm sure you can just check the Coastal Studies website too. They're good about showing all of their staff and how to get in touch with them.
My email is also on the abstract booklet for this conference.
Right. Thank you. Excellent. Thank you. All right. I've got a last question that I'm going to ask both of you. So Patty, what can folks who are tuning in today do to support your work specifically and in general research on diamondback terrapins in the area? Oh, we can't hear you, Patty. You're muted.
Sorry about that. That's a good question. Well, for Wellfleet Bay, I would say to continue to support the work is to support all of the coastal organizations that are working on salt marsh restoration, salt marsh protection, and diamondback terrapin monitoring. So that's Center for Coastal Studies and the Wellfleet Bay Wildlife Sanctuary. Anytime you see a terrapin like nesting in your yard, that's really great information. Call the sanctuary. And I think just being an advocate for, habitat protection and salt marsh protection. And if you live on the coast and you live in terrapin habitat and want to open up your yard for nesting, I mean, they could use it.
Great, thank you, Patty. Brian, same question for you. So what can people do to support your work and work about learning more about sharks in general?
So for directly my work, you can contact either me or the Center for Coastal Studies and specify that you would like to support the shark research. For regionally, both support the different organizations working on the shark research, and also contact your state and local reps. One way I was able to really get this project going is the town of Truro stepped up and saw the need for science-based decisions and help fund this. So towns can help, state and local reps can help if it's something that their constituents want.
Great. Thank you both so much. So we are going to wrap up. Thank you, everyone, for trying out a virtual conference with us. Thanks for your questions, for your patience, and for your enthusiasm about science in Wellfleet Harbor. The Planning Committee looks forward to seeing you next week for part 3 of the State of Wellfleet Harbor Conference. And we're going to learn about mapping responses to climate change next week. And I will close with the Haiku of Hope for Wellfleet Harbor, written by Mary C. McHugh. Inspire a fleet and call all hands on deck to make the harbor well. Thank you, everyone. Have a good rest of your Saturday.
Thanks, everybody. Bye.
We're getting lots of thanks.